Okay, so the agenda for today is as follows. We'll quickly introduce both our companies, and then I will move on to the problem description, the problem that we are trying to resolve, and then I will introduce the solution that we propose to integrate Capella and Jama Connect and talk about the benefits that this brings. Then there will be in-depth demonstration, several demonstrations actually, to show a bit all the features of the integration. And then we will just conclude and have a question and answer session. So as usual, you are invited to use the Q&A channel to ask your questions, because that's where we collect and sort the questions. The other channel is more for informal discussions as usual. Okay, so first of all, a quick presentation of Obeo and Jama software. So I will start. At Obeo, we develop cutting-edge modeling software to empower teams that design or transform complex systems. We are based in France with antennas in Canada, Brazil, India, Japan, and Australia. We are a strategic member of the Eclipse Foundation, and as such, we are very much involved in the open source community, contributing about 2,500 man-days of work every year in open source. We address three strategic domains along three axes. So open source, commercial software, and services are the three axes. We have an offer related to domain-specific modeling in general, where we develop and maintain series in open source and propose professional add-ons and services on top of it. Then we have an offer related to model-based systems engineering. That's why we're here today. We offer Capella and Sison in open source, upon which we propose several commercial software, including publication for Capella that we'll talk about today, and services as well. And finally, we have an offer related to enterprise architecture with a commercial software based on Sirius and associated services. Today, we will focus on the middle offer about MBSE, of course, because we are proud to announce the brand new compatibility, the brand new integration between Capella and Jama Connect that we've implemented in publication for Capella. And now, Patrick, it's your turn.
Yes, thank you. For those who are unfamiliar with Jama software, or if you just want a refresher, we are a purpose-built industry-leading requirements management tool. Our goal is to integrate requirements together with other tools to reduce cycle times, to increase your efficiency, and generally speaking, to improve your engineered products. And while Jama Connect is a purpose-built requirements management tool, it is truly agnostic to whatever industry you're a part of, whether it's space and defense or medical devices or automotive. Any engineering can take place in Jama. And so how does this really happen? That's what I'm going to show on the next slide. Here at Jama, we call our core feature live traceability, which integrates requirements from front end to back end of your product lifecycle together, as well as to other siloed tools like your MBSE suites or test management world. And so that's really the conversation we're going to talk about today, is how Capella can integrate with Jama so that you have that live traceability across all your tools and none of your teams end up siloed or with data that isn't connected. And that's really important, and I'll explain that on the next slide. To us at Jama, we know that most errors are introduced really early on. That's that green bar on the left side here on the chart. And they don't get found until later on, maybe in the middle there. That's why the blue line spikes of your life cycle for a system. But they cost more and more and more as they go forward through the end of the life cycle of your engineered good. And so what we want to do by connecting your data through live traceability in Jama Connect is bring that purple bar or that purple slope down on the far right and bring it over to the left so you find those issues earlier and can reduce the cost and the time to fix.
Okay, thank you, Patrick. So that's a perfect introduction to the problem description that I'll be talking about right now. Let's just say that I will have a less broad scope than Jama Connect itself, of course. I just want to talk about MBSE. MBSE sprouted from the statement that architecture needs to become essential to all the stakeholders involved in system engineering projects. MBSE tries to use formal models to capture and reason about architectural information that is needed to understand the needs, and come up with solutions that are acceptable and that cover these needs. If architecture model contain what's necessary to reason about a system and the associated needs, then of course many stakeholders need to access these models, and that's why MBSE specialists see the models as central to all the communication between all the stakeholders. We at Obeo advocate the use of Capella, not only because it's a great tool and it's free, but also because it has been designed to support a methodology called Arcadia. This methodology promotes a viewpoint-driven approach as per ISO 42010 and aims at helping stakeholders understand the needs by formalizing requirements, that's the top box, and designing a solution that covers these needs, that's the bottom right box, architecture building. Arcadia, for those of you who are not familiar, which I hope there are not many here, there are 4 perspectives in Arcadia. The 2 top perspectives focus on understanding the need, and the 2 next perspectives or layers focus on designing the solution, that is, how the system will do whatever it needs to do. So from now on, I'll be assuming that most of you are at least a little bit familiar with Capella, Arcadia, or modeling workbenches in general. What I really want to point out here is that the method itself emphasizes the importance of tracing the architectural concepts with the requirements. That's the red arrows that you can see between the purple box requirements and all the layers of the method. So it's really in the core of the methodology itself to maintain such traceability. In this context, that is working with Capella and Jama Connect, here are some of the challenges we face. As demanded by the method, we want to trace our architecture concepts with relevant requirements to justify our architecture. And we want to share as broadly as possible our architectures with many stakeholders so that the information flows fluently between everybody who needs it. Once we've traced design and requirements, we want to use this trace information to verify and report, of course. And while we are at it, why limit ourselves to requirements? As Robert mentioned just before, Jama Connect addresses not only requirements, but many other types of items. And also Jama Connect is not tied to a specific domain. It's exactly the same for Capella and Arcadia. The method makes it possible to design a system for any domain. And we don't only want to trace requirements, but we want to trace anything that makes sense, for example, change requests or test cases, to name a few. So in the rest of this webinar, we'll see how we address all of these challenges thanks to publication for Capella and Jama Connect. First, let's briefly discuss existing solutions. There is an open source Capella add-on that makes it possible to manage requirements through import-export mechanisms. It is based on a RecIF standard format for requirements. And well, one of the drawbacks of this approach, beyond the fact that doing the import-export is a bit cumbersome, is that the traceability information is then only available in Capella and nowhere else. So that's better than nothing, of course, but it's not the grail of what we are trying to achieve. Beyond this existing solution now out of the box in the open source community, the only other solution currently is to develop ad hoc integrations. We've seen a number of customers do that, not with Jama Connect, but with other repositories. In general, it consists in duplicating Capella objects into whatever repository they want to integrate with. And very often the feedback we get is that it's costly to maintain and not very effective to duplicate all the information everywhere and make sure it is synced, because as soon as you duplicate information, you're no longer sure who owns this information and whether it is up to date or not. So this is a pitfall we are trying to avoid with publication for Capella. So now I'll be moving on to the presentation of what publication for Capella is and how it works with Jama Connect. So with publication for Capella, we propose an approach that now works for Jama Connect users. That's the great novelty of the November release. That doesn't suffer from data duplication because we believe that each repository should own its own data and only manipulate this data. And what we need is just to trace information between these repositories, not copy everything around. We also want an approach that scales with the most demanding volumes and team sizes. But above all, we want something that is easy to use so that system engineers and other stakeholders will easily adopt it. So that's really key to have something that is as easy to use as possible. Here is a very high-level view of publication for Capella. Basically, it stands between Capella itself, where architectures are built, and Jama Connect, where requirements and also issues, test cases, or other artifacts are managed. Publication for Capella provides a web access to the model data and supports the traceability of the model elements with the Jama items. So there are two main use cases for publication. First, managing the traceability. We support Jama Connect, as I mentioned, because that's the novelty, and that's why we are doing this webinar today, of course. But we also support other third-party repositories, such as Polarian, Doors Next, Jira, and others. Then the second use case, beyond supporting the traceability, is to expose models online so that the content of models can be accessed and used by any stakeholder, any authorized party, without installing Capella or any specialist tool, and basically without anything more than a web browser. So we thus provide a true digital thread from requirements to architecture and vice versa. And this thread connects two sources of truth that own their data and nothing else. So that way we facilitate communication and collaboration around architecture models that are central in our approach based on MBSE. Okay, now I want to dive into the demonstration. So actually there's going to be several demonstrations, not everything at once. So let me explain the features first that I will be demonstrating. So first of all, I will show how models are exposed online. That's what we call publication, and how people can access this data online and consume it. So as we'll see, publishing models will not just produce some kind of HTML export. It will benefit from built-in access control, advanced features like search or historical browsing, and also there is professional support for using the solution. And there is traceability, but we will see that in a moment. So now I will switch to my demonstration environment. So if you still see my screen, which I hope, you should be seeing Capella. So for those of you who may not be familiar with Capella, it's a desktop tool where you can apply the Arcadia method to design a system that involves understanding the needs and capturing a model that describes these needs, understanding, and then deriving solutions that cover these needs and that describe how the system must be designed to cover all the needs. So the method provides these guidance. So for example, if I'm working on the logical architecture here, I see the list of activities that I may need to perform. For each of them, there are a number of diagrams that can be used to support the activity, and thus the tool guides me. So for example, here I have a diagram that describes a system. My system is a telescope, a simple amateur telescope that is designed so that amateur astronomers can observe stars and stellar objects. And here is the very high overview of how it works. The stellar object emits light. So this is what we call an actor, something that is a component that is external to our system. And this is a function in green, which is allocated to this component stellar object, this actor. So the stellar object emits light. The light reaches the primary mirror, which collects and focuses the light. This light is sent back to a secondary mirror that deviates the light to the observer. And then the light reaches the eyepiece, which converts the real image produced by the mirror to a virtual image that the astronomer can observe, and the astronomer observes this image. So this blue line that connects all these together is what we call in Capella a functional chain. This is one of the great concepts brought by Capella in Arcadia, which is very appreciated in general by system engineers. And basically here we have just a simple functional chains that groups together all the functions involved in observing a stellar object. Okay, so this is plain Capella. And when you are working with publication for Capella, you can just publish your model, which will contain all these diagrams, but also the description of all objects that you can find. For example, here you have a way to describe your model with rich text and some links. You have many diagrams that will be published. So we will see that all this information, the model tree structure, the rich text, and the diagrams will land online. So I will just hit publish to server like that. I want to update a model because I've already prepared everything and published it. Here it's asking me to log in. So I will just log in because I didn't log in for a while. Sorry, that's it. Now everybody knows my password. And I will just say publishing for demo purposes. I just timed out. Okay, that's it. Publishing for demo purposes. And this finishes my publication. All the data is crunched and sent to the server online. I'm just waiting for the response, and the publish was made. So all the data of my model is now available online. So let's see now how it looks online. I will switch to publication for Capella. So first of all, I need to log in. So as I mentioned earlier, there is access control. So I will log in with an authorized user. I will just use OAuth. And since I just logged in from the Capella client, I don't need to re-enter my credentials. The browser kept everything. So I'm now identified as John Doe here. And I have a list of projects that I am allowed to see here. There is only one for the purpose of this demo. That's where I published the Dobson model. So the Dobson model is really my Capella model here. And you can see that I will have exactly the same structure as in Capella. I will just put both close to one another to compare. So you can see that you find the same structure as you have in Capella. All the elements are identical. I can find also my diagrams here. Here I will just put it back full screen. The diagrams can be viewed in full screen if needed. Whenever you hover something, you will have a preview of that element. So for example, here I have a preview of the function that my mouse is hovering. If I hover more complex objects, I may have a preview of several linked concepts. Here I have a part and a component, so I'm previewing the component. Here I'm previewing the functional chain and its associated diagram. So this preview functionality is pretty useful when you want to understand what is referred from a diagram, for example. You can deactivate it just like that if you want to work with a colleague and review a diagram and you move your mouse and you don't want to have all these previews popping up all the time. Okay, so that's the diagram feature. Whenever you click on something, you navigate towards this element. So here I land on the page of the adjust primary orientation function with its description here. I also showed you earlier the rich text description of the model, which is here. You can see that it is pretty similar to what we had in Capella, which was here. It's exactly the same thing. The good thing here is that whenever you have something that references a diagram or an element in your model, you also have the preview working whenever you hover your mouse here in the rich text. So that's very handy. And many customers use that to document their model and make it easier for stakeholders to navigate through all that information. Okay, and then you have more advanced functionalities. First of all, you have a quick search. For example, let's say I'm looking for everything that contains emit. That's the function I was looking for, emit light, so I can go there. Whenever you need something more rich for research, you can do it like that. You can have a few words to search for. You can say, I want to search only logical, let's say, logical functions and logical components in the model Dobson, and I will hit search. I find 2 answers. The answers also can be previewed to make it easy to understand what they are. And that way you can find very easily anything you might be looking for. I will go back then to, let's say, a diagram. What do I have? A lab. Okay, this is the diagram I'm interested in. That's the diagram I showed earlier in Capella. Here you have a feature that shows all the changes that happened to this object. And the good thing with that is that you can preview the same object as it was in the previous commit. So here I'm hovering commit number 2, and I see the diagram as it was in commit number 2. You can see that there was no logical functional chain in this diagram. The blue lines were not there, whereas they are here now. So that's very useful, and it's available on any object, and it's also available on the model itself, where it's not filtered because you have all the changes of the model. And you can baseline any version of a model, just like that. And you can also browse the model as it was in the baseline just by clicking on the baseline like that. And now you're consulting the model as it was in this baseline you've just created. So the diagrams we have are as they were in the baseline and not as they are exactly in the latest version. So that's the history management features of publication for Capella. And I think I've gone, well, you have the properties view, which can be very useful. They are similar to what you have in Capella for any object. So they are basically showing the properties of anything you select. So here you can see this is an actor, as mentioned here, whereas this component is not an actor, and so on and so forth. Okay, so that basically covers the first use case I wanted to show you. I will go back to my slides, showing how interested stakeholder could access and consume the model information online without installing anything more than a web browser. So we've seen access control, we've seen the diagrams and the Capella objects, the documentation, the advanced search, the model history and baselines, and so on. So I think we can say that this covers the first challenge that we have to share architectures with as many stakeholders as possible and as easily as possible, while remaining secure, of course. So now we want to move on to the next feature, which is managing traceability. That's really the key feature with Jama, of course. So publication for Capella makes it possible to manage links between Capella model elements and anything hosted in a third-party repository, such as Jama Connect. And these links can be to anything. So we'll see requirements right now, and we'll see other things later. So this is the content of the second demonstration. I will show you how it happens in Capella itself when we want to manage traceability links, and how it also manifests online, both in publication for Capella and in Jama Connect. So I will move back to Capella here, and I also want to bring the web browser, which is here. Okay, I am all set up. So now I want to create trace links, basically. So first of all, let me introduce my Jama Connect test project that I use for this demonstration. I have a set of requirements here, functional requirements about a telescope that explains that the telescope must support the insertion and removal of standard eyepieces. It must allow the collimation of primary and mirrors, and so on and so forth. So this is my very small list of requirements just for the demo. And that's what I'm going to be tracing to my model on the left. So let's imagine that I'm working on the collimation use case. I want to explain that we support the requirements that say the telescope must allow collimation of primary and secondary mirror, this one. Okay, so that's DOPS FR11. I want to trace that with the fact that this is described exactly in this diagram, how we support collimation using a laser collimator. The laser emits light, and it makes it possible to adjust the positions of the mirror to collimate the telescope. So basically, the features are that we need to link to this requirement. There are several, but I want to link, let's say, the adjust secondary orientation. So I drag and drop simply from Jama Connect into Capella. And here it asks me what kind of link I want to create, because I configured several possible links. So I want to say that this function satisfies this requirement. At least it participates in satisfying the requirement. And as simple as that, if I drag and drop the same on the adjust primary orientation, the same, it reuses the same requirement, which is here, and captures the link between my function and the requirement. So you can see here in the diagram a summary of the requirements. Basically, we only use the ID, the API ID of the requirement. We display the type of the element and the title of the element, a shorthand of the title, but everything is available in the model here. And nothing more, because as I mentioned earlier, we don't want to duplicate all the information. If anybody wants to know more about this requirement, they just need to right-click on it and hit show online, and it will open the Jama software page on this requirement so that they can understand more about it. So that's sufficient and efficient, we believe. So I traced one requirement. Let's see if there are any others that make sense here. The primary mirror must collect and focus light to form a clear image. That seems exactly what we cover with this function of the primary mirror. So I want to say that this function satisfies this requirement. And okay, you can do that in any diagram. You can link anything you want. You can also configure and limit the objects you want to link to. I will not dive more into details. That's the main killer feature of publication for Capella, to make it very easy to create links in the Capella model from between Jama Connect items and Capella elements. Now that I have these links, I can show you that they are well integrated with everything in Capella. So if you select a function, you can see what it is linked to here in the semantic browser, which is a Capella feature that offers all the related elements of the selected object. If you select the requirement, you can see that it is satisfied by collect and focus light. If I select this one, it is satisfied by two functions. Okay, everything works just as expected. Now, this is for now only available in the Capella model. What would be great is that it would become available online, both in publication for Capella and in Jama. And of course, that's exactly what we do. So whenever we publish our model, I will republish it. And just here, I want to add a few links for the demonstration. My model gets published. You will see that in publication for Capella, the objects will be updated. And if I select the collimation diagram, you can see that it now contains these requirements that weren't there before. If I just select the previous commit here, you will see that the previous version of the diagram did not have the requirements, of course. So that's great. If you click on any of this, it tells you that it takes you in a new tab to the web page. So you have a navigation between publication for Capella and Jama. And here in Jama, you can see that you have a new link added here with a title, which is not very readable here, but here you can see that this requirement is linked to collect and focus light. And we have a technical link type behind that we use internally. And of course, this is the URL of this diagram. So if I, of the linked object. So if I click on it, it will take me directly to the collect and focus light function, which is the one that is linked. So I was collect and focus light was linked to this requirement. I clicked here, it took me here, and then we went back to the actual logical function linked to the primary mirror. On the object page itself, whether it's a diagram or an object, it's the same. In this external links panel, you see all the objects that are linked to the element. So this traceability information becomes available online whenever you publish. Now I want to show you a bit of the features. You can delete links in Jama, and this is taken into account in publication. You will see that in a few seconds, this is going to disappear. There is the data is pulled regularly, and whenever something, here it goes, we have deleted this link. So the information remains synchronized between the two repositories. And in Capella, if you want to retrieve that information, you have a feature for that, update from server, that tells you, oh, I noticed that this link was deleted, the link between collect and focus light and the requirement 10060 of type satisfies has been deleted. Do you accept this change or not? So that's where the system engineer has the responsibility of checking what happened online and saying, yes, that's okay, or not, I do not agree, this link is relevant and should stay. And whenever they hit finish, the change is applied, and you see the link between this function and this requirement disappear. The requirement remains here because there's no need to remove it. It might be linked to other things, but at least the link between the function and the requirement disappears. Okay, I'll show a bit more later, but I think that covers most of the features I wanted to describe. So I will go back to the slides. Here, we've seen how the system engineer can drag and drop and link objects from Jama in the Capella model, how this is taken into account when we publish the model, and how the links can be viewed, deleted, either in Jama Connect. It can also be done in publication for Capella. I don't have the time to show that. This is something, the diagrams as attachments, that we'll see in a moment. So I believe that this checks the other challenge that we had. And I believe that I need to accelerate a bit because we will be a tiny bit late. So bear with me, sorry for that. We'll move on to the next use case that I wanted to present, which is, okay, how do we use the traceability information that we have created? So basically, we want to take advantage of two open source components that we provide to the open source community. One is Python for Capella that I will demonstrate in a second, and the other is M2Doc that makes it possible to produce Microsoft Word documents, reports, or anything from the content of Capella models. I won't have the time to demo M2Doc, but you can have any information online. There are many demonstrations and data available online if you're curious. So let's just see Python for Capella in action very quickly. I will move back to here. In Capella, I want to build some traceability matrix. So I have added here a sample script, traceability coverage. This is a Python script. So we believe that many system engineers are very familiar with Python. So it's very easy for them to adopt this kind of tool. And Python for Capella makes it possible for them to write scripts that access the data of Capella models and the traceability information and use that. So this is a little script that just adds a little action when I right-click on this object. It adds the action traceability coverage for logical functions. And when I run this action, well, it just runs and tells me a report is generated. The rest is not to be worried about. And the report produced is here. If I open this report, it gives me this little report here, which takes the functions that I have defined in my model, the requirements that I have imported. So there are a few that I had imported before the demo. That's why there are not only 2, but more. And it gives me the traceability of these requirements with my functions. And you can see that I still have a lot of work to do to cover everything, because I only have 2 functions that are linked to 1 requirement. So there's, of course, a lot to be done. That's just to show how easy it is to build a script and use it to provide a coverage report, thanks to Python for Capella. So I'll move on with that, but that checks the third challenge to measure and verify coverage, for example. And beyond requirements, we would like to be able to trace more than requirements, as I already mentioned. And Jama Connect actually manages more than requirements, and especially it manages test cases. Well, it's an example that I like. So let's go for test cases. I will very quickly show you how you can link test cases. So I have a few test cases defined here. And I want to say that this align the mirrors. This is something that needs to be tested to verify that it works. And we have a test case for that, which is collimation capability test case, this one. So I want to trace this test case to my functional chain. As usual, I just drag and drop it. This is just my environment that has a very low limit on the OAuth token duration. So I want to just trace the collimation capability with this functional chain, and ta-da, it is traced to this test case. So you can see, compared to what we had before, this is a test case and not a requirement. But beyond that, everything works as easily. Something that's worth noting is that I have a diagram that describes this functional chain, and I think it would be handy for the people in charge of the test case to access this diagram. One thing I can do is just trace the diagram itself to the test case, which is done just by drag and dropping the test case on the diagram itself. And when I publish that, it will, let me do that. I move to publication once again. So, okay, it has been updated. We've seen the test case appear. That's great. So if I go to the functional chain diagram here, this is the diagram. Okay, you can see that this diagram is validated by the collimation capability. This is the test case. I clicked on it and it takes me to the test case page. And you can see on this test case that you get the LFCD attachment here. So this is really the diagram that comes from Capella. It is attached to the test case that is here. So that's very handy to have the attachment on the object itself. Okay, that's the last thing I wanted to show on this demo. I will go back to the slides. Okay, so beyond requirements, we can link basically anything that is supported by Jama Connect, and that's really great. Okay, I'm late, so I will move very fast. We can provide on-premises or cloud installations, and if we are on-premises, that's how it looks. In the cloud, we have an offer for that, which is called Cloud for Capella, where we can install everything for you and manage the deployment for you. So as a conclusion, this shows how you can broaden the audience of MBSE by exposing your models online, how you can create and maintain traceability links easily with Jama Connect items, how you can use this traceability information with Python for Capella or M2Doc, and everything is can be available on premises or cloud, is compatible with Team for Capella for those of you who know about Team for Capella. And please contact us or Jama Software to know more. I believe now is the time for questions, so I will just stop sharing and we'll go over the questions. Thank you for your attention. If Jama only sees a link, how is live traceability used to count traces? I thought that feature was looking at relations, not links. Okay. I understand your frustration. This is a choice we've made for now. It doesn't mean that it will remain that way forever, but we tried to achieve the kind of integration that we have with other tools that does not involve duplicating all the information in the repository. To be able to use live traceability as you imagine it, I believe we'd need to copy the Capella objects in Jama, and that brings a lot more questions, technicalities, and things that we would like to avoid as much as possible. So we have successful stories with other repositories. With this approach, we want to give it a try with Jama Connect, and I believe it's really worth trying. Robert, maybe anything you want to add with regard to this question?
Yeah, so I would say that, to your point, the trace view itself in Jama is predominantly used with the relationships. However, you can get some views that will show you the number of links and what they are and things of that nature in like the list view in Jama. So there are some workarounds. You're right, though. It is a little bit different than maybe what you were expecting with an item-based approach, but it does give you that one-click access to all the data you could ever need.
The server online, is it on premises or in the cloud, or could be both? Well, I believe I answered this question at the end of the presentation. It can be both as you wish. So let's move to the next question. Is there Python for Jama? I mean, Velocity and the API are good, but embedded Python in Jama would be amazing. I believe that's a question for Robert.
Yeah, that's a great question. So you can use the API with Python. We actually have a PyJama REST client that's available on our GitHub, but there is no way to currently embed Python directly in Jama and run the script in that kind of a manner. However, our team here at Jama does do some extended engineering services and builds different scripts and things of that nature. So if you ever need that kind of help, let us know.
Okay, thank you. How long could be the first publication, and is this an incremental publication? Well, actually, we test publication with a very high volumetries, so don't worry too much about the performance. Publications that can take up to a few minutes when you are using very, very large models with very high number of diagrams, but it's a matter of minutes. And as you can see with the small models, it's very, very fast. So this is something that we test regularly, and we make sure that the most demanding volumetries that we have ever seen in Capella models that involve several hundreds of thousands of model elements can be manipulated with a publication for Capella, and it is the case. Thanks for that question, because it's a very good question. And let's move to the next one. Is there any traceability matrix available in Capella or Jama to see all the requirements together to see if something is missing in traceability? Excellent question. So you're right. Whenever you want to build traceability matrix, you have to define the scope of what you are tracing. So whenever you are in Capella, the scope you have at hand is all the content of the Capella model. Here, the script I have made is very basic, but it makes it possible to easily ensure that a set of Capella elements is traced. So the use case would be verify that all the leaf functions of my model are traced to at least one requirement, for example. That would be easily covered. When you want the other way around to make sure that all the requirements of a given document are covered, that's more the responsibility of the requirement tool. So that would be in Jama. And here maybe Robert can enlighten us on what would be possible on the Jama side with regard to the approach we have.
Currently, I believe the most effective approach here is going to be utilizing something like a velocity report or an API script that generates your traceability view for this because it's utilizing the links. If it were an item-based approach, of course, we could talk about different approaches. But in the links approach, that's usually the smoothest, fastest, and most effective. It's also great because it gives you a timestamp when you generate that report of this is what the traceability looked like on this date, which is a very, very handy thing to have.
An architectural element could satisfy a good number of requirements. How clumsy can it get? Is there a way to hide, minimize, or do something to deal with the complexity? Excellent question. I will just move back to my screen just to show what you are talking about, because I believe my diagrams are already a bit cluttered. So, well, basically, there are many mechanisms that make it easy to manage this complexity. You can have any number of links here. You can add also the links like that. So bear with me, it won't make sense, but you can link components and functions, and you can end up with many links between many elements. So that, of course, is not very nice to have, but a few features that we have are the layers and the filters. So in Capella, you can easily hide a layer, and it basically hides your traceability information in the diagram, but it does not delete it from the model. All the traceability information is still there, and if you select your function, you will still see that, not this one, I don't know. Yeah, this one is traced, satisfies to requirement. So what I was showing is that in Capella, you have this traceability layer that you can deactivate, and it just hides the requirements, which is very handy. The information is still there. So if you select a function, it is still traced to something, but you just don't see it. And if you don't want to hide this and just want to hide a few, you can remove elements from a diagram without removing them from the model, or you can hide them. So to hide an element, it's just as simple as that. And to remove an element from a diagram without deleting it, it's like that. And in both cases, the diagram gets not cluttered, and the link is still there. That's what's important. So that's how we deal with complexity and with your question, which was this one. Is there any feature that automatically tells you something is changed? Well, not for now. This is something we could easily add in the future. Really, this is the first version of this integration with Jama Connect. We wanted to have something to provide to customers and have customers test and provide feedback so that we can evolve in the right direction. So this is typically something that we could add in the future. For now, we just listen to changes from Jama that are link deletions that are relevant to us. So whenever a link that comes from Capella is deleted, we react to the deletion and delete the link in publication. We could do the same whenever a requirement is renamed and so on. For now, the feedback we have from our customers is a bit mitigated here because it's also good to have an operation that is not, well, that is decided by the system engineer, and at some point he's ready to do that work. He will say, okay, I want to update from server, and then he will get a list of changes, analyze them, and deal with these changes. So the automatic part is maybe not such a good idea, but being able to detect more changes than just link deletions would be great. That's all for that. Next question. Can you see the traceability information towards Capella through Jama Live Traceability window?
So through the trace view window, you're not going to be able to see that currently. It's going to be through the list view that you'll be able to enable the links or the number of links and then be able to click that and see that information there.
Okay. Thank you, everybody, for your attention.